Hello everyone, I am Ajiti Kumar and welcome to my next video related to optimization technique. It is specific to how optimization technique is getting used in the field of data science, especially in the machine learning model or maybe some data science model. So let's discuss more about that particular thing. So if I am talking about optimization of the data science, so in data science there are certain life cycle of a particular model. Whenever we are building any model, because whether it is a machine learning model or statistical model or maybe any model in the data science, because machine learning used as a tool in data science, right? If I'm talking about any model specific to any model starting from problem statement or maybe gathering the data or maybe training that particular model or fitting that particular uh, equation behind that particular model, and again finally we are basically make it usable or make it available for the real world or for real user, right? So there is a certain life cycle is there. So optimization in data science means how in different places, different stages, optimization is playing the role. We need to discuss and understand more about that before starting any directly implementing behind any or maybe on the top of any data science or machine learning model. Let's start. So if I am talking about introduction to optimization technique in data science, so here I can say specially the optimization technique in data science involve the methods which is involving efficiency, accuracy and effectiveness in the data related tasks. Because again in data science data is our heart. Especially I can say how we will interpret the data, how we can take insights or maybe we can get result from the available data. So we can implement the different optimization technique on the top of the data only, right? Because data here is only and one input for us. On top of the data we will put some techniques to extract the meaningful insights for our problem statement or maybe solving the problem. So if I am talking about your importance, so it is basically very essential for fine tuning any machine learning model or maybe any model, optimizing the data pre-processing pipeline, extracting the valuable insights from the data. So fine tuning the machine learning model is a concept, optimizing the data pre-processing pipeline is a concept, or maybe a task under this particular lifecycle plan of the data science model, or extracting the valuable insights from the data. There are different tasks actually. But this is the introductory. We will basically definitely dive into that. But here the finally using the optimization technique in data science, our objective here is to find the best solution or configuration to achieve a specific goal while considering the constraint. We will consider each and every limitations, conditions, decision boundaries, because it's basically organization to organization or maybe policy to different policy to policy or constraint different. Constraint is different, right? So we need to take care each and everything. We need to consider each and every factors or maybe boundary decision boundaries into considerations while building this particular model or basically using this particular optimization technique. This is basically the, I can say, the basic introduction to how we are using optimization technique in data science. Let's dive more into that. If I am talking about first model training, we talk about machine learning model fine tuning, right? Again, model training is a life cycle step of a particular model because we are training the model. Training means we are basically fitting the equation, right? How basically optimization technique is getting used during our model training? First factor here is parameter optimization. Second is hyperparameter tuning. So there is a difference between parameter and hyperparameter. Parameter means during our training process, in the runtime, we will set the optimal value of the parameter. But in the hyperparameter, basically I can say one type of parameter, we will set it at starting before training. before starting with any specific setup of this particular model, we will start training. Before training, we need to just basically give some parameters to set a framework. This is known as hyperparameter. We cannot change the hyperparameter during our training in middle, no. So parameter optimization means setting the correct parameter value. We are using different optimization technique here. Gradient descent and its variance means stochastic gradient descent. So this type of basically is variants of the gradient descent technique. Definitely we will have the video into detailing out this particular mathematical intuitions behind gradient descent. So but these are the technique basically when using the train any particular model, adjusting the model parameter to minimize the loss function, because here this is a minimization problem, because we can minimize the loss by setting the appropriate parameter value. By setting the appropriate parameter value, optimization plays a very crucial role. Second is hyperparameter tuning, because as I said at starting, we need to take some setup of this particular model, architecture of this particular model. Whatever the architecture we will define, it should be a optimal value or optimal architecture. For example, architecture perspective, a learning rate, regularization strength, or network architecture. These are basically the fundamental, I can say, a necessary framework or architecture we need to set with respect to that particular model before training. We need to set it optimally. This is basically related to specific to model training. If I am going to next factor, feature engineering. Feature engineering means actually, so we are collecting the raw data. This is raw data from our source. We are doing data engineering on the top of that. For example, feature engineering. Data engineering specific means collecting the data, storing the data. These are the data engineering I can say, but feature engineering is a part, I can say, some special type of interpretation we are doing on the top of raw data using some statistical technique or advanced technique, or maybe we are using the optimization here, optimal technique. So to get a correct format of the particular data set, so that we can start training or start fitting our mathematical equation from this particular data set. We cannot take it, we can take basically the raw data directly into the model. Model cannot basically learn from this particular raw data. We need to convert it into the appropriate format. Data pre-processing we need to do. Under this particular data pre-processing, feature engineering is a part. For example, here feature selection. We are getting basically 100 characteristics of a particular thing. Which characteristics is more important for our problem? So that we need to decide. What are the maybe I can say these are the set of features which is actually required, and these are the features we can eliminate. This feature selection criteria we need to set up using optimization technique. Most relevant features, or which can basically improve the model performance or maybe reduce overfitting. In that way, this is the intuition we can think how we are using. That doesn't mean that we are explicitly using some technique. That mindset actually we are having, we will take it, or maybe we will keep it. We will basically define this particular thing in such a way that we can maximize our profit, or maybe maximize our efficiency. We can reduce our loss. This is how we can interpret this particular feature selection process, where actually we are using the optimization concepts while basically selecting the important features. Second is dimensionality reduction. So dimensionality reduction means, so it might be the case your data is basically defined, or maybe it's represented in multiple dimensions, in basically the hundreds of dimensions, right? So but hundreds of dimensions, basically I can say it's not relevant. It's the number of columns or maybe features, characteristics of a particular data set. It's, if you will basically take a object or maybe observation, a particular record, that means these are the number of dimensions of this particular instance of this particular value or maybe matter, right? If you will present it into a space, that will be that number of dimensions, the number of basically the characteristics, the number of columns we have. Most of the cases it is not important. Our basically we cannot fit a particular equation or train a model appropriately, we need to reduce the dimension. How we can reduce in such a way that, so out of 100 dimensions, we can present into 5 important dimensions. Some technique actually is used, for example, principal component analysis. Definitely we will dive into that in the later videos, but this is basically one example. Behind that, optimization techniques are getting used. This is specific to our feature engineering. If I am talking to next factor here, optimization of neural network search. Why I am talking about neural network search? We defined actually earlier during our deep learning introductory video, neural network architecture is there. So search means we are searching for a optimal solution or optimal architecture. So architecture optimization means optimization methods are used to search the optimal neural network architecture automatically, enabling the discovery of novel architecture tailored to a specific task. Because we are now working to solve this problem, particular problem. What should be the optimal architecture from a, I can say, set of architectures. Okay, there is, if I'm talking about set of architecture means there may be multiple possibilities. If you just change a single value, my architecture will be different. How can take it optimally? How can define this particular hyperparameter? I can say I discussed earlier, right? So hyperparameter of this particular architecture optimally. This is basically the, because why it is neural architecture search? It is searching for a optimal architecture. You are using optimization technique to define basically the optimal architecture design. This is the concept here. So if I am talking about the next session here, model evaluation and validation. Once we train our model, we need to evaluate our model or validate our model. Here we are using some cross validation. We are having certain different set of the data. We are validating basically the result, how our model is working, how our model learn from the basically the training data. So cross validation, this is a concept behind which the optimization technique is used to optimize the selection of the cross validation strategies to ensure that the robust model evaluation is, or maybe you can prevent the overfitting. Overfitting means it's basically a concept. This is not expected from a model. We can discuss. I don't want to be make you confused here. So this is basically a concept that should not be present in the model during our model training, right? We need to basically select a optimal cross validation strategy. Or maybe if I'm talking about a model assembles optimization. So basically optimization algorithms is basically employed to optimize the weights of the contribution of the individual model whenever we are talking, because ensemble method means when we are basically defining multiple models, model 1, model 2, model 3, means it's mathematical equations. So we are basically working for a problem statement. What should be the weight we should give for this particular model outputs, so that we can get a robust and optimized outcome finally. This is basically the criteria where we are implementing the optimization techniques or optimization mindset or optimization concepts also. Then my last point here is model deployment and optimization. Model deployment means we basically trained or evaluated a particular model. Then our final step is we need to make it available for the user, for the real world, right? So because whenever we are basically defining any model or basically preparing any model, at the later stage we are basically storing into a certain file. We need to do certain conversion, right, or some certain compression. During this particular compression, we are using optimization technique. How can large models for a deployment is resource constrained environment such as mobile device or edge device, or how can compress it? Under this particular hood, we are using optimization technique, different optimization technique. This is the maybe beauty of the optimization technique, actually how it is getting used behind any model or any concept of this particular model life cycle, or maybe model training life cycle, I can say, or maybe runtime optimization techniques like quantization and basically pruning to the apply to the optimize the model inference time of the model, the memory usage up to that particular point. Suppose our model is getting trained, how we can stop there, how we can find out the stopping point using optimization technique, so that we will not train our model further, because this is the optimal solution. In that point, by using this particular parameter of this particular model, we can get the optimal solution. We should not train it further. This is basically the beauty of optimization technique. Let's basically summarize into a single picture. So we are having optimization technique. We know there are different optimization techniques are there, right? And whatever our life cycle plan, basically data pre-processing, or maybe feature engineering is a part of here, data pre-processing, model development, or maybe model training, right, or model or maybe deployment, or model I can say model validation, right? So in each and every stage, basically optimization technique is getting used. Basically these are the high level points I highlighted, but this is not for all the major areas how optimization is playing the vital role, so I highlighted that. But that doesn't mean that these are only the restricted area. No, I have given some examples here, only some high level examples. These are the major areas where optimization is playing the very vital role. So it's very important to understand the techniques, how it is getting used under a particular model. Though we are using directly using some APIs provided by basically the third party companies, but still under this particular model they implemented this type of optimization technique, because we are using as a API, we are only calling this particular method and our model is giving us the output. But how it is basically they defined, they built this particular model, they provided us this particular API, right? Under the hood everything basically is mathematical conceptual, they built on the top of that. That's why it is very important to understand this concept before starting or directly implementing the things using API or maybe using some third party libraries. That's why I thought before starting or implementing directly into any model or example with any model, so I will start some conceptual video related to how optimization is getting used behind any model, or maybe for any machine learning model or data science models. In the later session, maybe we will start digging dive into the particular part, how and we will basically come with some mathematical intuitions or mathematical equations, how the things is happening behind, so that we will get better and better clarity related to how mathematics is working behind any model. What is the basically the maybe I can say foundations of this particular machine learning model or data science model. Thank you very much for watching this particular video. Please do subscribe my channel, also share this particular video. Also please put comments under this particular video, so that I can get some information related to your expectation, and definitely I will create the very comprehensive playlist related to each category. But now I'm basically starting with some introductory video and basically separating playlist wise, so that later stage based on this particular introductory video, so I will put the content detail wise, so that it will be we can get a path to understand, or maybe at last we can get a complete picture whenever we will go through the entire playlist. Once again, thank you very much for watching this particular video.